Hello friends, so in today's question, find the acceleration of block B as shown in figure A and B. There are two figures and we are supposed to find out the acceleration of block B relative to block A and relative to ground if block A is moving towards left with the acceleration A. Okay, so it's given that block A is moving with the acceleration A. So it is moving towards left. So let us consider for figure A, so it is given that block A is moving toward left with acceleration A, and we assume that the slack, let us name the strings first of all. We call this as 1, 2 and this is 3. So if block A moves towards left by distance x, then the slack produced in string 1 will be x, as well as slack produced in string 2 will be x. Okay, so we can say it as let block A moves toward left by a distance x, then slack produced in string 1 will be x, string 2 will be also x, and as a result of which the resultant slack, which will be accumulated in string 3, will be 2x. Okay, so you can say that thus, therefore the resultant slack to be accommodated in string 3 will be equal to 2x. And it is also given that block A moves with the acceleration A. Okay, you can say that acceleration of block A is given as A. Therefore, the acceleration of block B, thus the acceleration of block B will be equal to 2a. This is quite simple because the slack introduced in the string 3, or we can say block B, will be 2x, so it will be twice of a, that is 2a. Or we can do it another way also. We can assume that block B moves by a respective distance of y, so we can put y is equal to 2x, so we can write y is equal to 2x, double differentiate it, and we are going to get the same relationship, that is 2a. Okay. Now in this case we are going to find out two types of acceleration. First acceleration is relative to block A. Okay, so we find out acceleration of block B, relation of block B relative to, in the first part it is relative to block A. So in this case we can assume that the observer is sitting on the block A itself. Okay, we can say that this implies that observer is sitting, or we can say placed, on block A. So observer will be placed on block A and it will be observing the acceleration of B. Okay, so we can say thus the relative acceleration of block B with respect to block A will be equal to 2A. Okay, it will be seeing that the block B will be moving with the relative acceleration of 2A. In the second part, we are going to find out relative to ground. Relative to ground. So this implies that now the observer is placed on the ground. Okay, you can say that observer is placed on the ground. So it will be seeing that block A and block B will be moving with individual acceleration. Okay, so acceleration of A will be seen as A, block A will be seen as A, and acceleration of B will be seen as 2A. So we can say that thus the relative acceleration of block B will be equal to A minus 2A, which is equal to minus of A. Okay. This was the for figure A. Similarly, we can solve for figure B as well. Okay, you can say for figure B. So in this case also, the block A is moving towards left with acceleration A. So this will be the movement of with acceleration A, and we assume that block A moves towards left by a distance x. So as a result, we can say, let's name the string 1, 2, 3. Okay, so the slack in the string 1 will be x, 2 as well as x, and 3 will be x, and the resultant slack because of these three strings 1, 2 and 3 in the block B will be the individual summation, that is x plus x plus x, which will result in slack of 3x. Okay, so we can say that let the block B moves towards left by a distance x. Okay, so it means slack in string 1 will be x, slack in string 2 will be also x, and slack in string 3 will be also x. Therefore, the resultant slack accumulated in string 4, let's call this as string 4. String 4 will be equal to x plus x plus x, which is equal to 3x. Okay, and this we can say indirectly that this will be with block B. Okay, so you can say that thus the acceleration of block B will be equal to thrice A, as acceleration of block A is given as A. Now in this case also we are going to find out the relative acceleration with respect to block A as well as to ground. We find out in first part, you can say acceleration of block B. First part we can say A relative to block A, and in this case also we assume that the observer is sitting on block A. Okay, you can say that observer is placed on block A. Okay, so it means the relative acceleration of block B, the relative acceleration of block B with respect to block A will be 3. Okay, because the observer will be sitting here and it will be seeing that this is moving obviously at an angle, but with the acceleration of 3a. In the second part, we find out relative to ground. Okay, relative to ground, or we can say that observer is placed on the ground. observer is placed on ground. Now, if this is block B and this will be the acceleration 3a and acceleration a, okay, so it means the resultant of the acceleration, let us call this as AB, and this is angle of theta. Okay, this will be the various acceleration that will be observed by the person which is sitting on the ground. Okay, so we can say that acceleration AB is equal to 3a square plus a square plus 3a cos of theta and its whole square. Simple, we can say law of parallelogram, we can use it to find out the value. Okay, we get this as 9a square plus a square plus 6a square cos of theta square root. This will be 10. Okay, if we take a square common from the entire square root, we can see that a, this will be coming as 10 plus 6 cos of theta and its square root. So this will be the acceleration of B, or we can say relative acceleration. Okay, you can say this AB is a relative acceleration of block B with respect to ground. Okay. Thank you.